Okay, welcome to the 6th video in the linear algebra and modeling sequence. This is called Solving Systems via Linear Equations. And if you recall previously in the past lesson, we had taken this system of equations here and rewritten it using matrix notation. So we did this. We decided that we were going to call the vector x, that's going to be equal to the vector x, y. I believe in the last lesson we called it x1 and x2, but this is fine. We changed these equations into negative 3x plus y equals negative 2 and 5x plus y equals 6, which we convert into matrix notation by making the matrix negative 3, 5, and 1, 1 times the vector x, y is equal to negative 2, 6. And I don't like the way that x looks. Let's do that again. X, there we go. That's a good x. Okay, and you can see that that negative 3 and 5 correspond to the coefficients of x up here, and 1 correspond to the coefficients of y up here. Okay, so we're going to take this and we're going to rewrite this. We're going to change this. We're going to put this into R right now. Okay, so we're doing that down here. We've got A is equal to a matrix, and we're passing it a vector of the values negative 3, 5, and 1, and then we're saying that there are 2 rows in this matrix. And then we're saying that B is this solution vector over here. B is this, and B is negative 2, 6. So I'm going to run that, and then let's have a look at them and verify that they look like what we expect. Yeah, A is this matrix, negative 3, 5, and 1, 1. And the solution is negative 2, 6. Now, we saw in the last lesson, we saw this solve function, and we just run it. Remember, this is what this is going to be solving is AX equals B. This is going to be giving us X so that X is equal to A inverse B. So solve is we're passing A here and B here, and we're going to get the solution 1, 1, which is what we're looking for. All right. And, we've got this question down here. Does this match the solution that we found previously? Yes, that was the solution that we found when we solved this analytically. We found that 1, 1 was the solution to this system of equations. So we have the same solution to this system, whether we solve it analytically, whether we plot it, or whether we use linear algebra to represent it.